All right, class, welcome back. This is, I think, the sixth installment. I have no idea, I've lost track of factoring polynomials. These concepts are taught in 5.5 to 5.7 sections, and right now we're going to talk about two-term polynomials. Specifically, we're going to talk about sum of squares right now. So, sum of squares, the definition of a sum of squares is that the first term is a perfect square. A perfect square means that I can break it down to a factor times itself. And this one, it would be 5 times 5. Also, the second term is a perfect square. So you can see the first term is a perfect square, the second term. Here, the first term and the second term is a perfect square. Here, the first term and the second term is a perfect square, and here not so much. So let's see. So definition again of a sum of squares is that I have two perfect squares that are being added together, a sum of two squares. Okay, and the moral of this story is that these are prime. Prime means it can't be factored. Now we're going to talk about why real quick. Well, what if I was like, no, this totally can be factored? Why wouldn't it just be x plus 5 times x plus 5? Well, if I were to multiply this back out, my firsts, my outers, inners, and lasts, I end up with x squared plus a 10x plus 25. And you can see, whoops, this is not what I started with. Okay, so that's not so hot. That's not going to work. Well, maybe I got the signs wrong. Maybe it should have been minus. Maybe I did something wrong there. So let's go back and say, no. What if it was x minus 5? X minus 5. Yeah. Okay, so if I just FOIL here, I get x squared minus a 5x minus a 5x plus a 25. So that gives me x squared minus 10x plus 25. And like, dang it. Again, I didn't get what I started with. The whole point is when you factor something out, you should get what you started with. But I didn't get that here. Okay, well maybe, I know why. Probably they should have been opposite signs. That was the problem. So my only other possible sign combination is I've got two positives, two negatives, or a negative positive. So what if this was a x plus 5 and an x minus 5? So, and then I'm going to FOIL this back out just to check it. X squared minus a 5x plus a 5x minus 25. Okay, and these sum to 0, so I get x squared minus 25. And oh my gosh, this is so close, but it's a minus right here. So those do not match. There's no other possible sign combination I could try here. So I know anytime I see a perfect square and a perfect square with a sum here, this is prime. I don't have to go through this process if I can recognize this out the gate. So I'd literally say, oh, yep, perfect square, and say, hey, this is a sum of squares. Stop right there, and I'd say, nope, this is prime. Okay, I do the same thing here. Perfect square, sum, prime. Perfect square, sum, this is prime. Okay, but this one isn't a perfect square. 3 is not a perfect square, and neither is 27. So I'm going to have to go back to my steps here and say, I've got to factor out a GCF. Well, I know that this didn't have a GCF because this didn't have an x and this didn't have a constant, but these ones I didn't really check. I should have, and this one is just 1, so there's no GCF there. Here, there's a GCF, and the GCF is 3. When I factor out a 3, I get y squared plus 9. Sweet. Okay, so this factors, and then I look at inside. Remember, after I factored out a GCF, I'm going to look at inside and say this is a two-term polynomial. This y factors to y times y and this 9 factors to 3 times 3. That means this is a perfect square and this is a perfect square. But I've got a plus sign right here. So am I just going to slap on a prime here and say done diddly undone? No, this is not prime because I did factor it. Stop, alert, abort. I factored it, and this is the answer with the greatest common factor here. So remember that prime means it's not factorable. This was factorable. I factored out a 3. So while it won't factor further, because this is prime, the whole thing is not prime. Okay, so that is our sum of cubes. Again, this is in section 5.7, this concept, and we're talking about two-term polynomials here.